Hello, you're welcome back. Okay, so we are still on Kirchoff laws, all right? Here we're going to be solving another question. Okay, so I have another circuit here before me that I need to analyze. So the question goes this way: calculate the branch current in 15 ohm resistor by applying Kirchoff laws. Okay, so we are looking for this branch current passing through this 15 ohm resistor. Now this circuit is somehow more complex, okay, different from what we actually treated before. Why is that? Because there are two voltage source. Okay, so one voltage source from loop 1 and then another voltage source from loop 2. So in this case now everything now changes. Okay, so the movement of current changes, as of course you know very well that current will move from the source, from loop 1. Okay, from the source it will move and enter into a branch. Now, the very first step in Kirchhoff law is to apply the very first law, that is current law. And for us to apply current law, you know very well that we need to actually select a node, right? A node is that point where current actually branches. So let me call this the node, the reference node, node A. So that means the source current from loop 1. Now this time, since I have two source currents, so I won't just use I. Okay, I used I before because I had only one. I had only one source. Okay, so I use I, but now having two sources from loop 1 to loop 2, so I can call the source current from loop 1 I1. All right, and it's flowing into the node A, and now the same thing happens to the source current. So I have to, okay, let me remove this arrow. So the same thing happens to the source current, okay, from loop 2. It will still be flowing. Of course, you know, we know that current moves from negative to positive, so it will still be flowing into the node A. So at the two current reaches node A, it will now branch. Okay, so let me call this the current from node 2 to be I2. All right, so as they reaches node A, they will now branch and enter into 25 ohms resistor, and let me call that the current I3. So you discover now if I'm applying Kirchhoff law, it will be different now. Why? Because the current I1 and I2 is flowing into the node A, while I3 is leaving the node. So according to Kirchhoff law, I can simply say that, okay, I3 is going to be equal to I1 plus I2. The sum of the current entering to a node, okay, is equal to the sum of the current leaving the node. You know that that's Kirchhoff law. So of course, let me just call it KCL. So having gotten that, now I can now apply my loop. Remember my equations, I need equations so that I'll be able to solve, get my current. Okay, I need system of equations. So how do I get those system of equation? From the loop laws. Okay, so the first is the KCL, the current law. Then I will now use the voltage law to get my equation. All right, so now let's apply KVL, voltage law. Okay, I'm going to start with loop 1. So if I'm starting with loop 1, of course, you know, I'm going to move this way, that's clockwise, right, around loop 1. And according to KVL, okay, the algebraic sum of the voltage around a loop is equal to 0. Okay, so that's exactly what you're going to do. So that's going to be a flow from 10 volts, and don't forget our sign convention. Okay, if you are going around the loop, once a current reaches a particular resistor, okay, that particular terminal is positive. So for this 10 ohm, here is going to be positive, here is negative. As it enters 25 ohm, all right, here the very first terminal is positive and there's going to be negative. It flows again. Okay, as it reaches 5 ohm, here is going to be positive and here is going to be negative. All right, so let's flow with the law. So now, starting from my source, the current move from negative to positive. So that's going to be plus 10 volt. Then enter and now move and enter into 10 ohm resistor. Okay, you know how we get the voltage according to Ohm's law. That's always current times resistance, right? So now, and that's going to be negative voltage. Why? Because I'm now moving from positive to negative. Remember, if you move from positive to negative, it's always a voltage drop. All right. So I'll use negative. So that's going to be minus 10, of course, multiplied by the current flowing through 10 ohm resistor. That's I1. All right. Then I now move again, enter into the branch and pass through 25 ohm. All right. So, and as I pass through 25 ohm, I still go from positive to negative. It's still going to be a drop. Okay. That's going to be minus 25 being the resistance, then multiplied by the current. Now, remember what we already stated, that I3 is going to be equal to I1 plus I2. Okay. This current I3 is the sum of I1 plus I2. So, I'll just state that since the current passing through 25 ohm is I3, so it's equal to I1 plus I2. So I'll just put that inside here, I1 plus I2. Okay, as I now move again through 5 ohm resistor from positive to negative. And that current, okay, so that current is also going to be the main current. Remember, the 5 ohm resistor, okay, is from the source, loop 1 source. Okay, so the source current, which is I1 from loop 1, is still going to be the same current that will pass through the 5 ohm resistor. All right, so, and it's going to be negative. That's going to be minus 5 I1, right? So equal to 0. Okay, so before I call it equation 1, let me actually simplify it first. All right, so let me open the bracket. If I should open this bracket, I'm going to have minus 25 I1. So if I sum the I1, I have minus 10 I1, minus 25 I1, and minus 5 I1. Okay, minus 10 I1 minus 25 I1 gives me that minus 35 I1, and minus 35 I1 minus 5 I1, that's going to be minus 40 I1. Okay, now remember, all the I'm going to take them to to the other side of the equation. So since I'm having minus 40 I1, if I move it to the other side of the equation, it's going to be okay, plus 40 I1. So let me just write it down here. Okay, open it. If I still open this bracket using, I'm going to use minus 25 to multiply I2. I'm going to have minus 25 I2. And if I move minus 25 I2 to the other side of the equation, it becomes plus 25 I2. Okay, so while the voltage 10 volts still remain at one side or source, I'll call this my equation 1, equation for loop 1. Okay, so let's now go to loop 2 for another equation. If I go to loop 2 this time around, you know how we go. Okay, if I believe that I'm going from negative to positive, that means this time around I'm moving in in an anti-clockwise direction. Okay, so if I'm going in an anti-clockwise direction, okay, you know very well that already this have been atomized as I reaches the current. This is going to be positive and this negative, right? Okay, so let's flow with that. Starting with the source from negative to positive, that's then I enter into 25 ohms. That's going to be minus because okay, of course you know very well this is going to be positive and this negative. That's how it flows. So that's going to be minus 15 I2. Okay, then I enter into the branch where I have 25 ohms. Are still, that's from positive to negatives. Another, the voltage is a voltage drop. Okay, that's going to be minus 25. Of course, multiply by the current I3, which we already know that is the sum of I1 and I2. Then I now flow again, now passes through 20 ohms resistor from positive to negative. And of course, the main current is I2, all right? The main source current of loop 2. That's what is going to be passing through the 20 ohm resistor. So if I go, okay, pass through it, that's still going to have minus 20 I2. Okay, so everything equals 0. All right, so simplifying my expression and of course rearranging my equation. Okay, so of course you know what I'm going. This is going to be minus 15i2. If I open this bracket, I'm going to have minus 25i2, right? Minus 15i2 minus 25i2. Okay, minus 15 and minus 25, and that should give me also 40. Okay, so I'm having minus 40i2. Okay, so let me write that minus 40i2. Okay, minus 40i2. Oh, by the way, I'm going to move everything to the other side. So I have minus 40i2. Okay, I've not finished adding. This is minus 25, minus 15i2 minus 25i2. That's minus 40i2, and I still have another minus 20i2. All right, so that's going to be minus 60i2. If I move it to the other side of the equation, it's going to be plus 60i2. And don't forget that I have minus 25i1. Okay, so if I move that minus 25i1, that's going to be plus 25i1. Okay, then of course minus 60i2 to the other side, that's going to be plus 60i2. All right, then of course equal to the voltage 25. So this is now going to be my equation 2. So I'm going to combine these two equations simultaneously to get my I1 and I2. All right, so let me write them down. Okay, so I'm having from equation 1 40i1. All right, then plus 25i2 is equal to 10. Equation 1. Then from loop 2, 25i1 plus 60i2 is equal to 25. Equation 2. All right, so how do we solve this? We solve this simultaneously. I think elimination will work. Okay, and before I actually eliminate, I'll make it easier for me, okay? Because the coefficients are really very large numbers. I can actually break it down since they have a common factor. Equation will have a common factor, and that's the common factor is 5. So I can use the common factor to divide everything so that I will break the expression down into smaller coefficients to make my solution easier. Okay, so if I divide 40 by 5, of course I'm going to have 80. So I have 80i1. Here, if I divide 25 by 5, I'm going to have 5. That's 5i2. Okay, so of course if I divide 10 by 5, I'm going to have 2. Okay, still that's my equation 1 broken down. So do the same to equation 2. If I divide 25 by 5, I'm going to have 5i1, then plus 60 divided by 5, that's going to be 12i2. Okay, 25 divided by 5, that's going to be 5. Equation 2. So with what I have now, let's solve simultaneously. So I'll do that by elimination. So I have to make one variable to have the same coefficient, all right, so that I can eliminate. So which one do I eliminate? Okay, let me eliminate I1. So if I should eliminate I1, I have to multiply equation 1 by 5. So that I1 will be 40i1. Then I multiply equation 2 by 8 to still give me 40i1. Okay, so 8 multiplied by 5, I'm going to have 40i1. Okay, 5 multiplied by 5, 25i2. Then 5 multiplied by 2, that's going to be 10. So I can call this now equation 3. Okay, so the same happens. 8 multiplied by 5, that's going to be 40i1. 8 multiplied by 12, 60. Oh, please pardon me. 8 multiplied by 12, what is it exactly? It's not 60. That's 96, okay? 96i2. And of course, 8 multiply by 5. Should be 40, right? Yeah, 40. So I can now eliminate by subtracting. So I'm just gonna subtract. I'll do equation 1 minus equation 2. Equation 1 minus equation 2. So if I subtract 40i minus 40i, I'm going to have 0. So I is eliminated. So I'm having 25i2 minus 96i2. Let's do that. 25 minus 96. Okay, so that's minus 71. So I'm having minus 71i2. Okay, and of course 10 minus 40, that's gonna give me minus 30. Of course, minus cancels minus, right? I'm now gonna have I2 now to be equal to 71 divided by 30. Okay, so let's do that. 71 divided by 30. What do I have? Please, 30 divided by 71. Please pardon me. What a mistake. It's 30 divided by 71. Not, okay. 30 divided by 71. So that is gonna be 0.4 approximately. So, and that's exactly what I'm looking for. So you can actually get because we are asked to find the current, okay, passing through the 15 ohm resistor, which is I2. So for you to get have your I1, it's just gonna be very easy. So all I just need to do is to substitute. Okay, substitute I2 being equal to 0.42 ampere. Okay, into any of the equations. So I'll put it into equation 3. Okay, please, pardon, what I subtracted was equation 3 minus equation 4. So correct that. That wasn't 1. Okay, that's what I subtracted here. Okay, so now if I should substitute I2 being equal to 0.42 into equation 3, okay, you know exactly what I will have. So where's my equation 3? Where's my equation? Okay, let me put it in equation 1. It is much easier. Equation 3 is of a higher factor. So I'll put it in equation 1. So put that in equation 1. Okay, so that's gonna give me 8i1. My equation 1 is 8i1, then plus 5i2. That's gonna be 5 times I2 is already 0.42. Okay, it's equal to 2. All right, so let's do this. 5 times 0.42. That's 2.1. All right, so invariably now I'm gonna have 8i1. Okay, is equal to, of course, 2 minus 2.1. Okay, which we know that is 0.1, right? So that means I1 now is gonna be equal to 0.1 divided by 8. So the 0.1 divided by 8, what do I have? That's 0.0125. So that's my I1. And of course, if you want to get the I3, you know I3 is equal to I1 plus I2. So invariably now you are just going to add I1, which is 0.0125, then plus I2, which okay is 0.42. So just as simple as that. So that is how we apply our Kirchoff laws Okay, so this is another example. All right, so we are going to look at more examples. See you in the next video. Thank you very much.